So today we're going to be looking at the review for the test this Friday. This is Unit 4. So we're going to be looking at inverse trig functions first. So for these problems and for like the whole review sheet and the test, you're going to want to have your formula sheet up for the semester. And again, it's found on the weekly agenda. Okay, it has not only the unit circle, but the half angle formulas that we're going to use at the bottom half of our review. All right, starting with our inverse trig functions, we're looking for the inverse tangent of 1. So the inverse tangent, you're only looking at the right side of your unit circle. And because we're looking for positive 1, we're looking at the point that is root 2 over 2 divided by root 2 over 2, which is at pi over 4. All right. Then we have to find the cosine and then the inverse sine of this problem. All right, so now that we have pi over 4 from the inverse tangent of 1, we're going to find the cosine of pi over 4. So the x value of pi over 4 is root 2 over 2. All right, and then finally the inverse sine of root 2 over 2, like the like the inverse tangent, inverse sine is only using the right side of the unit circle. Okay, so for positive root 2 over 2 and the y value, that is again pi over 4. And that's it, you're done. There's nothing else to do. Number 2. All right, the tangent of 5 pi over 4, so if we go to 5 pi over 4 and find the tangent, it's going to give you negative root 2 over 2 divided by negative root 2 over 2. So negative divided by negative is a positive, so we have 1. Okay, now, although we said for inverse tangent you're only using the right side of the unit circle, this is not an inverse tangent. It's just a regular old tangent function. Okay, so you can use the whole unit circle. All right, so next we have the inverse sine and then the cosine of that answer. So for the inverse sine, again, you're only using the right side of the unit circle. We want to find out where sine is going to be 1. Okay, so where is the sine value, the y value, going to be a 1? On the right side of the unit circle? Well, it is at pi over 2. And then finally, the cosine of pi over 2, which is the x term of pi over 2, is equal to 0. That's our answer. All right. Cosine of 5 pi over 6, we'll look at 5 pi over 6 and the cosine. The x term of 5 pi over 6 is negative root 3 over 2. So the inverse sine, only the right side of the unit circle is what we're looking at. So the y value that is negative root 3 over 2, excuse me, is found at 5 pi over 3. However, remember, we can only use the right side. Well, we can't go around the unit circle to get there. We have to go backwards on the unit circle, which means 5 pi over 3 is the same as negative pi over 3, which is your answer. For number 4, inverse cosine of root 3 over 2. Now for the inverse cosine, unlike tangent, inverse sine, we're using the top half of the unit circle for the inverse cosine. So we're trying to find the x value where it is root 3 over 2, and that is at pi over 6. And the tangent at pi over 6 is sine over cosine, which is 1/2 divided by root 3 over 2. We multiply that by the reciprocal of the denominator to get rid of our complex fraction. This will cancel, those two cancel, and we get 1 times 1 is 1, 1 times root 3 is root 3. We're not allowed to leave square roots on the bottom of our fraction, so we multiply to the top. And 1 times the square root of 3 is the square root of 3. Square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is just 3. There you go. So those are inverse trig functions. Let's look at the equations. Okay. Now normally for an equation I like my variables on the left and my numbers on the right, but in this case I'm going to make an exception. I'm going to subtract 5 sine of x. Okay. The signs work just like variables. So I'm going to have square root of 3 equals 3 minus 5 is negative 2 sine of x. Divide both sides by negative 2 to get the sine of x by itself. So I have, I'm going to rewrite it. Sine of x equals negative root 3 over 2. So now we're looking for all the values that sine is negative root 3 over 2 in one rotation around the unit circle. So any y value that is negative root 3 over 2 in the unit circle is going to be at 4 pi over 3 and at 5 pi over 3. That's it. And number 6, to get cosine by itself, the first thing to do is divide by 4. So cosine squared of x equals 3 over 4. Excuse me. To get cosine by itself, we're going to square root both sides to get rid of that squared sign. Okay. Now the square root of 3 is just the square root of 3, but the square root of 4 is 2. Now the other piece that most students will forget is when you square root both sides of an equation, you have to put plus or minus. So we're looking for all the positive and negative root 3 over 2's in the x values of your points on the unit circle. Now, so that would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All 4 of them. Number 7. This is a factoring type of problem. You could do this problem by taking 2x squared plus x minus 1 and factor it, and then once you factor it, put the cosines back in for the x's. That's a strategy you can do. If you don't want to do that, you don't have to. It works the same with just the cosines. So we have 2 cosine of x times a cosine of x. To factors of negative 1 would be 1 and 1. We need a positive right here, so that means this has to be plus and this has to be minus. Excuse me, my goodness. All right, so now we have our factors. We're going to set them equal to 0. So 2 cosine of x minus 1 equals 0, and cosine of x plus 1 equals 0. This cosine of x is going to be, if we added 1 and divided by 2, it's going to give you 1/2. This one, if we subtracted 1, it would give you negative 1. So we need to find all the x values on our unit circle where the x term is 1/2, positive 1/2. That is at pi over 3, and that is at 5 pi over 3. All right, on the other side, cosine of x equals negative 1. There's only one of them, is at pi. Oops. Have a little coughing issue. Okay. 8. For this problem, I'm actually going to bring the negative sine x back to the other side. So I'm going to have 2 sine squared x plus sine of x equals 0 by adding sine of x from both sides. Now, this one has squared and this one does not, which means they're not like terms, so it's not 3 sine squared of x or 3 sine of x. You're just adding to the other side, and the reason I want to do that is now, when I have my 2 terms, they both have a sign in them, so I can take one out as a greatest common factor. I'll be left with 2 sine of x on the left side and plus 1 on the right. Now with my 2 factors, I set them both equal to 0. Okay. The one on the left is already solved. The other one, if I subtracted 1 and divided by 2, I get negative 1/2. All right, so I got to find the radians for these values. So a sine of x equals 0, so all the y values that are 0, there's actually 3 of them. There is 0 pi, there is 1 pi, and there's 2 pi. 2 pi and 0 pi are coterminal, but they're still in one rotation around the unit circle. That's those 3. Then at sine of negative 1/2, so all the values where y is negative 1/2, there are 2 of them. It is at 7 pi over 6, and it is 11 pi over 6. Okay. Next, there's a hint for this one. So cosine squared is also the same thing as 1 minus sine squared. So we're going to use that to our advantage. Equals 2 sine of x plus 2. Okay. I'm going to move the stuff on the left all the way to the right because I don't want this squared term to be negative. So I'm going to subtract 1 and add sine squared x. So I will have sine squared x plus 2 sine of x plus 1 equals 0. Okay, much like the problem above it where I could factor it, the same thing applies to this. I could make it x squared plus 2x plus 1. If I wanted to, factor it and then replace the x's with the signs. I don't need to do that, but I could. So sine x squared is sine x times sine x. The factors of 1 are 1. And to get a 2, I just put both be pluses. Okay, so it's the same thing for both, so I only need to solve one of them. So I have sine of x plus 1 equals 0. This will give me sine of x equals negative 1. Okay, now where is sine going to be negative 1? There's only one spot on the whole graph for the unit circle, and it is at 3 pi over 2. All right, number 10. All right. When I'm doing this problem, let's see, what do I want to do? I want to bring this, I have to get the square root sign by itself, so I have to bring this cosine to the other side by subtracting it. There's also this negative sign, so I'm going to divide both sides by negative 1, which just changes those. I'm just going to do that, saving me some space. Now that the square root sign is by itself, I can square both sides. So I have the square root and the square root cancel out. I get negative 3 cosine squared x plus 1 equals cosine squared x. Okay, if I add the negative 3 cosine squared x to both sides, I would get 1 equals 4 cosine squared x. All right, then I would divide both sides by 4. So I get 1/4 equals cosine squared x. And I would take the square root of both sides to get rid of that squared sign. So the square root of 1 is 1. The square root of 4 is 2. And because I square rooted both sides, it'd be plus or minus equals cosine of x. So I got to find all the x terms on the unit circle where it is positive or negative 1/2. So that gives me 4 of them. I have pi over 3. I have 2 pi over 3. I have 4 pi over 3. And I have 5 pi over 3. Okay. Number 11. I'm going to add square root of 8 to the other side. So we have negative 4 sine of x equals square root of 8. We divide both sides by negative 4. So I have sine of x equals negative square root of 8 over 4. All right, I'm going to give you a little hint. I know we didn't really do this in class, but this is part of the review, so it's not a big deal. I'll show you what it is. If you could reduce the square root of 8, you would get 2 root 2 over 4. These would reduce, and you'd get negative root 2 over 2. Now, that's a little bit something we didn't really go over in class too much, but that's because we ran out of time. So we have sine of x equals negative root 2 over 2. So we're looking for all the y values where where the point, the y value there where the point is negative root 2 over 2. There are 2 of them, at 5 pi over 4 and at 7 pi over 4. Number 12. Okay, so we're going to add 3. So we have 2 tangent squared x equals 2. We're going to divide both sides by 2. So tangent squared x equals 1. We're going to square root both sides. So tangent of x equals plus or minus the square root of 1, which is 1. So all the places where tangent is going to be positive or negative 1. That is going to be 4 spots. It's going to be all of the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. For this tangent, it's kind of like the problem we had above in question number 8, We had two sine values. We can take the greatest common factor out of the tangent, so we're going to have tangent of x is equal to the tangent, I'm sorry, that's not right, times the tangent of x plus 1 equals 0. Okay, so if we have the two factors, we have tangent of x is equal to 0, and the tangent of x plus 1 equals 0. All right, if we solve the second equation by subtracting 1, we get these two things. So where's tangent of x going to equal 0? Okay, so you got to do the y divided by x's where they're not going to be undefined. That happens in 3 spots. It happens at 0 pi, 1 pi, and 2 pi. For the tangent of x where it equals -1, it happens twice. It's at 2 of the pi over 4s. Okay, it's where the x and the y are different signs. So it happens at 3 pi over 4, and it happens at 7 pi over 4. All right, last equation. All right, this is similar to the one we just did with also the sine function. We have a sine, a cosine, and a sine. So out of our two different terms in our equation, we have two sines that share that are common. We can take one of them out. We're left with 2 cosine of x plus root 3 equals 0. So now we have two equations from this based on the two factors. Sine of x equals 0. If we subtracted root 3 and divided it by 2, we'd get negative root 3 over 2. So where does sine going to be 0? It happens 3 times again at 0, pi, and 2 pi. Now where's cosine of x going to be negative root 3 over 2? It happens twice at 5 pi over 6 and at 7 pi over 6. All right, those are the equations. Let's look at some half-angle formulas. Okay, so looking at the bottom of our formula sheet, where the half-angle identities live. Okay, first we're going to look at the sine one. So to get this value, 5 pi over 12 is going to be in our unit circle about here. It's going to be important for later when we're trying to find the sign of it, like if it's positive or negative. Excuse me. For now, we're going to multiply this by 2, so we get 5 pi over 6. And we're going to use 5 pi over 6 in our formula. So our formula is plus or minus the square root of 1 minus cosine of our x term, which is 5 pi over 6, divided by 2. Okay, so if we look at cosine of 5 pi over 6 in our unit circle, we find out that 5 pi over 6 is negative root 3 over 2. So we have 1 minus, because it's part of the formula, negative root 3 over 2, divided by 2 with a big square root sign. I'll get the plus or minus at the end when we are done with the whole problem. So don't forget about it. Okay, we have to combine the two fractions on top with the 1 minus negative root 3 over 2. This will become 2 plus root 3 divided by 2, all over the other 2. With our complex fraction, we're going to multiply by the reciprocal of 1/2, because that's 2 over 1, on the top and the bottom. Okay, so we get 2 plus root 3 times 1 is 2 plus root 3. 2 times 2 is 4, with the big square root. All right, but the square root of 4 is just 2, so we can just have 2 plus root 3 over 2. All right, so now we're done mathematically with the problem. Now we have to figure out the sign. So in this location, in the quadrant, in the first quadrant, the sign values of all the terms in that quadrant are positive because it's above the x-axis. So the y values are all positive. So this graph's going to be a positive. Or sorry, that answer's going to be a positive. 416. Let's look at our unit circle again. Pi over 12 is going to be like right here. Now we don't know the value of pi over 12, but we're going to use the half-angle formula to find it based off our half-angle identity. All right. So we're going to multiply this by 2 to give us pi over 6. So the formula for this is 1 plus cosine of pi over 6 divided by 2 with a big square root, a plus or minus. Okay, so we have 1 plus pi over 6 is going to be, off the top of my head, I don't want to think, root 3 over 2, that's what I was thinking, divided by 2 with a big square root on top of it. Again, we'll get to the plus or minus at the end of the problem. Again, we need to combine the two fractions at the top, so we're going to get 2 plus root 3 over 2 divided by 2. Multiply by the reciprocal. So we have 2 plus root 3 over 4. And then the square root of 4 on the bottom gives you 2. So we have 2 plus root 3 on the top over 2. Now the cosine in this quadrant, the x terms in that quadrant are all positive, which means our answer is also going to be positive. All right, now let's look at two tangents. All right. So 11 pi over 12, when we look at this, it's going to be over here. Oops. 11 pi over 12. Okay. We multiply it by 2, we get 11 pi over 6. So our formula for this is 1 minus cosine of 11 pi over 6 divided by 1 plus cosine of 11 pi over 6, the big square root. Okay, so 11 pi over 6, the cosine of that is root 3 over 2. So we have 1 minus root 3 over 2, 1 plus root 3 over 2. Oops, that's not a 2. The big square root. All right, much like before, we need to combine our fractions. We're going to get 2 minus root 3 over 2 and 2 plus root 3 over 2. All right, also like before, we have to multiply by the reciprocal of the denominator to get rid of our complex fraction. So these all go away, and the 2's go away. But the other ones don't cancel out because they have different signs between them. In order to cancel, you have to have the same exact expressions, and we don't. So we have 2 minus root 3 on the top, 2 plus root 3 on the bottom. From here, if you remember back from the notes, we're going to multiply by something called the conjugate. The conjugate is designed to get rid of square roots on the bottom of your fractions when you have expressions. The conjugate is the same terms with a different sign in between them. So the term that we're trying to get rid of has a plus, this is a minus. This has nothing to do with the fact that it's 2 minus root 3 on the top. It's irrelevant. Oops. It has everything to do with the fact that the bottom is 2 plus root 3. Okay, so if I multiply that out, I'm distributing. 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. Negative root 3 times 2 is negative 2 root 3. And negative 3 times negative 3, negative root 3 times negative root 3 is positive root 9, and the square root of 9 is 3. On the bottom, 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. Positive root 3 times 2 is positive 2 root 3. And positive root 3 times negative root 3 is negative root 9, which is negative 3. Okay, again, you have a big square root on the top. Now we can combine the like terms. We have 4 plus 3 is 7. Negative 2 root 3 minus 2 root 3 is negative 4 root 3. On the bottom, we have the two terms here cancel themselves out because they're exactly the opposites. And then 4 minus 3 is 1. Well, the square root of 1 is irrelevant. We don't need it. So we can actually get rid of this denominator altogether and put our square root on the top of our answer from the top. All right, which brings us back to the original part of the problem. What is a tangent function over in this quadrant? Well, since that quadrant has negative x and positive y, it's a negative number. That means this would be a negative answer. There you go. Okay, one more and we're done. I don't know why this parentheses is there, but it's irrelevant. Okay, so our tangent in this part, 7 pi over 12 is going to be here. Okay, we're going to multiply this by 2 to get 7 pi over 6. So for tangent again, we have 1 minus the cosine of 7 pi over 6. 1 plus the cosine of 7 pi over 6 with a big square root and a plus or minus out in front. So we're looking at our unit circle at 7 pi over 6. Cosine at 7 pi over 6 is negative root 3 over 2. So this is going to give you 1 minus negative root 3 over 2. And 1 plus negative root 3 over 2. Combining our fractions, we'll get 2 plus root 3 over 2 and 2 minus root 3 over 2. All right. Much like before, we're going to multiply by the reciprocal. These all go away. But on the top, we have 2 plus root 3. Bottom, we have 2 minus root 3. All right, once again, we're going to use the conjugate, which is going to be the same terms with a different sign. And it has everything to do with the denominator, it has nothing to do with the numerator. Okay, so 2 times 2 is 4. 2 times root 3 is positive root 3. Sorry, positive 2 root 3. Root 3 times 2 is, again, positive 2 root 3. And root 3 times root 3 is positive root 9, which is positive 3. On the bottom, we have 2 times 2 is 4. 2 times root 3 is positive 2 root 3. Negative root 3 times 2 is negative 2 root 3. And negative root 3 times times positive root 3, I'll get it, is negative root 9, which is negative 3. Combining like terms, 4 plus 3 is 7, plus 2 root 3 plus 2 root 3 is 4 root 3. These two cancel on the bottom, and 4 minus 3 is 1. So we don't need to write anything in our denominator. Again, looking back at our original problem, 7 pi over 12 is in this second quadrant, and the tangent of those, again, is going to be a negative x and a positive y, which means it's going to be a negative number. And that concludes the semester. Okay? Please make sure you study, watch the video, do whatever you need to do to get ready for the test, which is going to be Thursday/Friday.